All right, continuing to move through time. Now we were up to the unit where we talked about waves and sound. Okay, so we're just going to go through a few wave properties here. This is a mechanical wave. Okay, so we've got a position versus time graph here. We can see our waveform moving along. So let's talk about some of these different properties. Amplitude, remember, is like our max displacement from our equilibrium line. Our equilibrium line is this line along zero that runs through the middle of the wave. So this is my amplitude. And this would also be an amplitude, like they're going to give you the same number. But if we look at our graph here, I can see that this is on 2 meters. Okay, so my amplitude is going to be 2 meters of this wave. Okay. All right, and then using my graph, what is the frequency of the wave? Okay, so remember, what is frequency? It's our number of cycles per time. Remember, frequency is 1 over period. Sorry, I'm losing my voice. Period is 1 over frequency. Period is our time to complete a cycle. So let's look at this graph. To complete one cycle, it takes us 4 seconds based on this graph. All right. So my frequency is going to be 1 over 4. 1 cycle over 4 seconds. And then my period is going to be 1 over that. When I flip that up, I'm going to get 4 seconds. And I can see that 4 seconds is my period here. It takes 4 seconds to complete a full cycle. Okay. And that means that one cycle is going to, I think how to explain this. One cycle takes 4 seconds. Okay. And then the inverse of that is frequency. So 4 seconds per cycle, 1 over 4, 1 cycle every 4 seconds. Okay. And then lastly, we've got, if we're given the wavelength, remember that's our little symbol here. What is the speed of the wave? Speed equals frequency times wavelength. That's an equation we used last unit, and we've been using it in this current unit. So I'm going to take my frequency 1/4 multiply by 15. So I'm multiplying frequency by wavelength. Okay, 1/4 is 0.25. So then I'm going to multiply that by 15. And that's going to give me 3.75 meters per second. This is a speed. So it's going to have the same units that our old velocity did from last semester of meters per second. Okay. All right, and then lastly, we've got electromagnetic waves. So we're covering Snell's law here, which we've been talking about. We're about to have a test over this. So Snell's law says that our index of refraction of our first material times the sine of the angle of the light wave going through that material equals our index of refraction of our second material times the sine of that angle. Okay, so this is our, so let's draw these coming in. Okay, so in this example, we've got a light wave coming through air. It's got an n value of 1. It enters, and then it's going to enter a diamond. Okay, so the angle of incidence, or my theta 1 here, is going to be 38 degrees. So this is my angle of incidence, or incoming angle. All right. Then when it goes into the diamond, it's going to bend. It's going to bend. In this case, it's bending towards this normal or perpendicular line. It's going to bend to an angle of 15 degrees. Okay. And we want to know what the end value is for the diamond. Okay. So this is my angle of refraction. This is where my light wave bends when it goes into another material. How much it bends, and how the direction of the bend depends on how the materials compare to each other in terms of density. Okay. But if we want to solve for that, we're going to use this equation. N1 is equal to 1, so I don't have to worry about that. I'm not even going to write 1 there. I'm going to have the sine of 38, that's my angle of incidence, equals N2 times the sine of 15. Okay. And I want to solve for N2, so I'm just going to divide both sides by the sine of 15. Remember here, sine is just giving us a number. We're not doing any trig functions. We're just going to put it in our calculator. We're going to make sure we're in degrees, because if we're in radians, we're not going to get the right answer. And I'm going to do sine of 38 divided by sine of 15. And that gives me 2.37, so about 2.4 for my end value of a diamond. Note that that's a good bit higher than air. Okay, so that's why my light wave is bending towards this normal line. It's because a diamond is denser than the air. Okay, so 2.4 is my answer there. All right, hopefully that will do it for our performance final study guide.